Hello. In this video, we'll try to do a problem from Virginia in 1992. Uh, so what we have in this problem is a polynomial, and then we're told that R is a root for that polynomial. And then what we're asked to do is to simplify this expression over here down to 2. And then we're also given some restrictions on x so that we don't divide by 0. Okay. So scratch. Okay. Well, okay, so p of x, so R is a root for p of x, so that means p of x, that means x minus R divides p of x. So you can rewrite p of x as x minus R times q for q of x for some polynomial q of x, and then this is x squared plus dx plus e. The coefficient for x squared is 1 because the coefficient for x cubed is 1, and then the coefficient for x is 1 here. When you divide them, when you multiply them, that only 1 gives you 1 over here. Yeah, meaning like if you had 2 over here, you'd have gotten just 2x cubed instead of x cubed, 1x cubed. Okay, so if we rewrite p of x as like this, in this form, then p of x over x minus r is simply q of x, because this cancels, this term cancels the denominator, and then the same thing happens to the other terms as well. So p of x plus 1 over here, p of x plus 1 over x plus 1 minus r. That, yeah, this is q of x plus 1, because the denominator is cancelled by the term over here. So when you plug in x plus 1, you get x plus 1 minus r. And then the same thing for the other term. So p of x plus 2 over x plus 2 minus r. This is q of x plus 2. Okay. So now we can rewrite this long expression in terms of q. So that would be q of x minus 2q of x plus 1 plus q of x plus 2. And then this is, if we plug in the expression we have over here, to q of x, we get x squared plus d of x plus e minus 2, and we plug in x plus 1 into q of x, we get x squared plus 2x plus 1 plus d dx plus d plus e, and then we plug in x plus 2 and into q of x, and then we get a x squared plus 4x plus 4 plus dx plus 2d plus e, and plus e. And then if you notice, we have an e over here, another e over there, and then a minus 2e over here. So those sum to 0. And then the same thing for x squared. We have an x squared over here, another x squared over there, and then a minus x squared over here. So these also cancel out. And then likewise for d of x, there's one d of x over here, d of x, another d of x over there, and then minus 2 d of x. Yeah, and then we have a minus 4x here, 4x there, so those cancel out. Yeah, and then we have 2d over here, a minus 2d, and then a plus 2d over here, so that those cancel out as well. Then what we're left with is a minus 2 on this side and a 4 on the other side, and when you add them, you get a 2. Indeed, that's what we wanted, right? Okay. And then, yeah, and then I just rewrote everything that I said. Well, yeah, you can write pfx as a multiple of two polynomials. Yeah, there's that, and then yeah, everything is just what I just said.